In the future, we will see new materials and devices, and they will change our lives. Organic electronics can absorb DNA, viruses, and organic gases, generating electrical signals that provide information about a material's identity. Such organic electronic devices can be printed, a manufacturing process that is much simpler than existing methods. Being lightweight and bendable, these devices can be incorporated, for example, in clothes, plastics, and paper. Refractive index modulation between the dark and bright regions on a photopolymer is generated by the interference of two coherent beams. If a collimated beam illuminates the grating, a 3D hologram may be generated by index modulation changes that alter the beam diffraction. Holography is a future display technology that reproduces an object image, spatially varying in a realistic way, derived from the reconstruction of light scattered from an actual image. Cognitive devices are chips capable of self-learning and function, much like human thinking. If we use oxide instead of metal for the CPU interconnects, binary data can be transferred, which, in turn, can be applied to real-time, simultaneous interpretation.
This interesting story features a rabbit deceived by a terrapin, saves his own life by wit and wile.
For your illness, the rabbit liver is the best medicine.
With graphene, carbon atoms are connected in a hexagonal net. Being the world's thinnest nanomaterial, electrons move 100 times faster than with silicon. And graphene, being highly elastic, can be easily stretched or bent without compromising its electronic features. Thanks to these characteristics, graphene will be essential for next-generation bendable displays, electronic paper, and wearable computers.
If that is true, Mr. Terrapin, go and get a rabbit's liver, as you are well aware of the situation on the land.
In the future, object coloring can be dynamically changed using tunable photonic crystal dyes. Photonic crystals are periodic nanostructures where high and low refractive index materials are aligned in regular arrays. By tuning the array, different colors can be selected. Optical data interconnection systems that are faster than electric signals, at low power consumption too, will drive the computers and memory systems of the future, enabling tremendously faster data transmission speeds.
You are always insecure on the land, as you may get devoured any time. So isn't it good for you to live in the Sea King's palace comfortably?
The Sea King's illness is critical. Give your liver to him.
I really wish to do so, but as my liver is desired by so many, it is highly valued. That's why I hid it in the forest, under a rock. It is impossible to live without my liver, so I would like to leave for the land to bring my liver to you.
In plasmonic devices, coherent electron oscillations are coupled to light waves on metal surfaces. One example is an optical hyperlens, which can be used to obtain very high-resolution optical images by which the decaying light from nanometer-sized objects is amplified via oscillating electrons in the stack of thin metal films.
Air condition.
In the future, we will see environmentally friendly heating and cooling systems that do not use Freon, as thermoelectric materials will provide next-generation refrigerants, in which the same materials can be used for both heating and cooling. In the future, gallium nitride and silicon carbide power devices with higher energy conversion efficiencies will be preferred over silicon devices. With electric vehicles, gallium nitride power devices will enable the interconversion of electrical power between battery and electric motor with power losses less than 1% of today's silicon-based technologies. The future promises ever more innovative and effective substances and materials. Smart devices change your life.